Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. Today we have a Grafana race condition, a Mastadon exploit, some cross-site tracking, and a confused deputy vulnerability in AWS. As per usual, the Spot the Vuln solution will be covered at the start of tomorrow's episode, and you can check it out in our Spot the Vuln channel on Discord. This one's a little bit funny because it was like a challenge I was working on that was incomplete, but it kind of got forgotten about, like the nuances of it. So that's why the challenge is a little bit weird with you know the code having some oddities, like some of you spotted in chat, like the body length of the title. So yeah, it's a bit of a weird spot to bomb, but there is a solution. So yeah, feel free to give it a go, and we'll cover that on tomorrow's episode. All right. So we'll get into our first topic, which is a post by Datadog Security Labs on a confused deputy vulnerability in AWS AppSync, which is a developer service for creating GraphQL and publish subscribe APIs. And it's one of those attacks that's kind of unique to cloud, although the underlying issue ultimately does come down to like a parser type bug. Z, I'll let you take this one away.
The underlying issue, is very stupid and very definitely an old trick. But yeah, the context is kind of where you end up having the core vulnerability here. And basically with AppSync, create your app, you create data sources, and it's going to create from your data source, it can create like a GraphQL endpoint or API that can then be used. In creating the data source, you basically have to create a role that AppSync will then assume, and it will give it access to any of like a DynamoDB or whatever service you're using to actually store the data you want to provide. You'll provide it through there, or you'll create the role that it can assume, and then you create your new data source and tell like here's the role that you're going to assume, and it does some validation on that role, checking like, hey, does this role actually belong to this AWS account? So you can like add a role from another account. And when using the JSON API, you're going to pass that in with this service role ARN. Um, and you'll pass in the ID or the ARN for that role, and it does a check. The problem with this check is it seems to be case sensitive. If you send in the service role ARN as all lowercase, it'll still get used, but it will basically just skip the validation. It confuses me why this happens because I would understand if there's like a parser differential. You pass this in twice, and one time it reads it as the one with like the proper capitalization, the other time without, normalizes it later. That makes sense, but completely skipping the validation, I don't even know
Yeah,
what
I
the
found it
code
weird
looks
too.
like.
Yeah, I was thinking about that. Like, it's weird that it would still work, but skip the validation. It's like I couldn't really like think of how that would happen in the code. It's kind of
Yeah,
strange.
like I would expect it to be something like, "Oh, we couldn't find this," and throw an error because you didn't provide it, not, "Oh, we couldn't find this, so it must be okay." The only thing I
Yeah,
could think of is if you can create a data source where it doesn't assume a rule, but that also just doesn't make sense. Um, I didn't validate that's the case, and there aren't some other use cases. If there was one like that, then I can maybe imagine it. But I don't believe that's the case, that you can actually send it in without one. So the fact that it bypasses when you don't send it doesn't make sense to me. But yeah, it's a really old trick for bypassing filters of just changing capitalization. So they use the example of going all lowercase, but you could do the what are you going to call that, satire case? Changing every
yeah.
letter. You could.
That's a good name for it. Actually, I never really thought of how to coin it, but yeah, like doing the alternating lowercase uppercase letters. Yeah,
Alternating is
um,
probably more descriptive. But
yeah,
yeah, I mean it's a fun issue to see here. It's really surprising to see it. 'Cause like I said, the how the backend works isn't exactly obvious to me. Um, it is also a little bit of an ask that you would, in order to abuse this, basically just means you can bypass that check of whether or not that ARN actually belongs to your AWS account. So with that, you would be able to add a role that belonged to anybody else's AWS account, add that um into AppSync and use as that. But it would require that other role trusts the AppSync service and allows it to be impersonated. So you would have to know another role belonging to another account that trusts AppSync, which feels like a bit of an ask to me. It feels like the sort of thing that maybe later on in like a pen test, you might have been able to abuse this. Obviously, they fix it now, so you couldn't, but where you maybe get access to a bunch of things and then you toss it into your own account so you can play around with what you can get access or something. I'm not sure how you'd really go about exposing the ARN, like just a random account, but it does let you bypass if you know it. But I do think that's kind of a mitigating factor. You do need to know it.
For sure. They do mention a case this could be taken advantage of. They basically leverage like phishing in their hypothetical case. So they're like, if there's like an event planner app which uses GraphQL for scheduling meetings and stuff, if an attacker could phish some employee and gain access to the ARNs, even if they don't have access to the database themselves, they could then use their own AWS account and do that.
Yeah,
But
that's
it relies on phishing, and like you said, you would need a foothold already. This would be like a second stage attack,
yeah,
basically.
that's where I saw it kind of tying in with like a pen test or something where you get access to it through some method and then you can escalate. But on its own, like it is a bit of an ask to have the ARN value.
Yeah. But you are still able to get access to a data source you don't own, assuming you can get it. And considering how widespread use of AWS is in the industry, that is like a fairly powerful attack vector. So yeah, I mean it's still a totally a valid issue and worth pointing out, but there is some limitations there on needing to know that ARN. I don't imagine that's going to be a super common case that you run into as an attacker anyway. Yeah. So with that said, we'll move on to our Grafana race condition. This one's a bit of a fun one, where it involves golang and races in golang, something we don't get to talk about super often. Um, Not a ton of information in this write up, unfortunately, but I know Z dug into it a little bit more, so I'm going to let him jump into this one.
Yeah, and I'll just start off with what they have here in the summary is really all the information that they give out is an internal security audit identified a race condition, the Grafana codebase, which allowed an unauthenticated user to query an arbitrary endpoint in Grafana. A race condition HTTP context creation could result in an HTTP request being assigned the authentication authorization middlewares of another call. That stood out to me as being really interesting. Being that it is a Golang application, um, and this sort of race condition bypass is just, well, I mean, it's a little bit weird. So I did dig into it. I came across the actual patch for this, which pretty simple. Uh, Basically, just they copied this m.mws. That way, it will basically have its own copy. But let's talk about the core issue being second. I thought I had a more source information available, but here we go. So the way the context ends up working, or as a request comes in, request handler, it comes in, creates this callback every time the request comes in. It's going to create the context, which is where we just looked, where it's saying that m.mws, which is just an array of middlewares. Kind of at a high level, the server has its middlewares, and then every request can have the middlewares that it's going to add to it. And that's where it goes through and starts appending the middlewares to it. So the issue here is that the MWS, so in this case, it's grabbing it c.mws, which is just grabbing it from that context. And that's what we saw before, where just in the original code, it just assigned it from this M or macron, whatever that, however that's supposed to be stated. Um, Kind of like their global server for requests coming in, of course. Um, it could spin up multiple of these. It does the whole like server factory style thing where it's spinning these up. But effectively, that's a global list that it's just assigning into the context and then appending to it. And that's where the issue comes into this because of the fact that that's a pointer just to a global list. A lot of people using append will kind of think that's actually going to create a new list every time you append to it. But what's actually happening is it's just sharing kind of this one storing Uh, or let me back up. In Golang, if you want to append something to a list, you end up having this kind of standard looking call where you have the variable name append, and then you pass that same variable into it, and then the data you actually want to append. That's kind of the common format for doing the append, and it gives you the idea that the response you get from append is a new list. And in fact, if you were to take like the old list and try and print it after you do an append, like you won't see anything appended to it. You do actually need to grab that response. But that's because it's basically like a header that you're getting back that says it's this wide and here's the backing memory store. I'm sure there's some more implementation details there, but that's the gist of it. Uh so what ends up happening is it keeps reusing that backing store, that backing memory every time. And so if you have multiple requests coming in, they can both start with that same list and start appending to it and actually change from out underneath another request the middleware that's in that list. So this race condition is effectively doing this use of append on a global object because of that misunderstanding. And it really it's a I think a good example of kind of so technically it's not Golang specific. You could do something similar in other languages, but it's one of those issues that it's a code pattern to look for specifically in Go when you see this sort of append that assumes it's kind of getting something new when it's actually not. It's being shared. So I thought it was interesting to look into because it is Golang, does have some of its own little quirks.
Yeah, I do want to state I don't think it's guaranteed that it's going to append onto the same slice of memory. It's kind of up to the Go runtime to decide what it wants to do. It'll try to append if it can to be more efficient, but then if it gets too large or whatever, I think it will do like a new allocation somewhere else. It's just not
It-
really like up to you. You don't really have influence over that at a high level. The Go runtime decides that.
Kind of, yeah. So that's another piece of the internal information is that there's a capacity value. So it'll be created with capacity for like 8 items at first or something. And then once you try and append or grow it outside of 8, it'll create a 16 element thing. So yeah, it will kind of reallocate it as needed and does that in a somewhat intelligent way, doubling every time it hits the limits. Yeah, it does do that also, so it can return something new. But it won't always. It shares that same backing memory. And I don't know, just this pattern because it feels like you're getting something new every time. I understand why a developer might write the code thinking that because it kind like just naturally rating it, I would think it's giving something new,
Yeah,
even though that's
because
not good for performance.
yeah, it's interesting because it's kind of it's like a low level memory management is involved quite heavily in this issue, but like Golang tries to abstract away all of that from you. So if you were dealing with like raw pointers and stuff in C, this would be a little bit more obvious, but where the Go runtime, you don't really have the concept of pointers in Go, at least not unless you go into like CGO or whatever.
Well, you
um
do have you do actually have a lot of people don't realize you can actually use the unsafe keyword and Go and do raw pointer stuff. It is
you
there. You
can,
can do it. And you
yeah.
do have like you'll notice like our router here, you do have the little pointer symbol. It's more used to indicate like this can be mutable. Um, rather than like, but it does mean it's being passed by reference rather than value. It does go more ref value rather than pointer exactly. Like there are some semantic differences. Like you
Yeah,
do have a concept that's similar.
but that's why these kinds of issues crop up, is because most go code or go developers aren't going to be using unsafe or pointers, and probably aren't even aware that you can do that. So
I've never seen
Golang,
it outside
yeah,
of like Maldev.
yeah. So the Golang runtime is going to have to take some liberties, and you're going to have to be aware of some of these weird edge cases with it. Because yeah, like slices are really nice in Go, but the underlying memory management is not obvious. It's not intuitive. Um, so yeah, this seems like a very easy edge case to overlook. And honestly, like I write Go a lot, and if I saw this, I don't really know if I would catch the problem. It's like it's one of those problems where I feel like it would have to happen to me, and I'd have to see the behavior to find out that it's even like happening. And it's like rock, like just static code review, I don't know if I would catch it.
Yeah, it's
So
really easy to overlook. And I kind of feel the same way. Like now that I'm more familiar with it, I'm familiar with that. I could probably find it if I were doing like a Go code review.
yeah,
Or if I was looking up like what are the Go specific gotchas. This is something that can come up there. But if you're just a Go dev, super easy not to catch it.
yeah, and so good to be aware of this type of problem. So yeah, always fun to see some Go issues because it is like a memory safe language, so we don't see it a lot, especially on like the binary episode or anything like that. This is kind of like going into like binary type issue category, although it's not like quite the same. But yeah, it's a fun issue.
It does take
It's a bit of
place
a
at
unique one.
yeah, takes place at the binary level, but at the same time, like in terms of exploiting this, it is a race condition, so I figured it kind of fit in here a little bit more.
Yeah. All right. So our next topic is by Portswigger, Gareth Hayes of Portswigger specifically, and is about stealing passwords from Mastodon. So yeah, Mastodon is the hot new thing with all the Twitter drama going on, and so that kind of prompted them to start looking at it. And when they started looking at it, they noticed the fact that you could enable HTML on Mastodon. So he was like, this is kind of weird and seems a bit dangerous. So
Sounds
let's dive
dangerous.
down the rabbit hole. Yeah. And after studying the code a bit, they found an attribute. The attribute title could be controlled and allow arbitrary input. So we started playing with it. It didn't really seem like it would be super useful immediately, but eventually,
Yeah, one
through
quick
looking at other,
clarification, sorry. Arbitrary input, but they still couldn't break out of the title. They could
no,
include like the single or not, sorry, not single quotes, angled brackets for HTML, but they couldn't break out of the quote. So mostly arbitrary.
that's a fair point to raise. So yeah, but then they started noticing that people had these like verified icons in their names, and they started asking around, like seeing, okay, what's the deal with that? And they found that you can essentially use emojis. In this case, colon verified colon, and it would get replaced with the icon. Um, which would be an image tag underlying in the HTML. So he tried using the emoji and injecting some HTML there to try to inject his own elements, and it ended up working. He had HTML injection. He was effectively able to use the emojis to break out of the tags, and break out of uh, the attribute title. So yeah, it was an HTML injection. There was a strict CSP in place, so he was somewhat limited in what he could do. In the end, he created some hidden form fields and took advantage of Chrome's autofill to demonstrate the attack, which could be submitted with some interaction. It's kind of a classic trick, I guess, for HTML injection where you're limited by a CSP. So yeah, like not really a new attack, but showing that these kind of older vulnerability types can exist in newer software. Because yeah, I mean, using like emojis and whatnot to break out of like HTML attributes and whatnot is a bit of an older trick. I haven't seen it in a while, but yeah, it was able to be used here. I'm not super surprised something like this was found in Mastodon. This is one thing that, like, I got into some conversations with people, and I didn't understand why everyone was flocking from Twitter to Mastodon, because Mastodon outright says that it's in like a beta stage. It's been in development for a few years. Uh, Even the like lead maintainer of it states that it's not really like production ready. So yeah, I mean, I'm not super surprised this kind of issue exists. I don't know how old the like that emoji support is, to be fair. Maybe it is a couple years old, I'm not sure, but yeah, I mean, it makes sense to start looking at these other platforms that people are going to. People are on the thought line that Twitter is going to implode soon or something. So there's a lot of people going to Mastodon. So,
No, I
it's good
mean,
to do some auditing of it, but
so I agree with the auditing. No, I just kind of said, I don't know. But when it comes to jumping over, I feel like, Twitter might go the route of Facebook, largely irrelevant, but still present. I mean, it has a pretty massive market to completely die, but I guess we'll see. I haven't really used Mastodon much myself, and I mean, I don't use Twitter much, so I'm not the best person to compare that. But talking about the actual issue here, I thought it was fun. He said we haven't talked about that sort of thing a lot. I think we've only had maybe one other topic on the podcast where we've had that style of excess. The basic trick is definitely common enough, well known enough. It's just that idea of finding something that's going to get replaced and basically inserting it into an unexpected context. In this case, inserting it into the attribute and then hoping the scanner kind of just does the complete scan and doesn't look for the attribute or happens before or whatever. Like getting the order mixed up. And then it kind of breaks itself out. We talked about an XSS like this in I believe it was a BB code parser, where you would
Ah, I
do
remember that
something really
topic.
similar. I want to say it was like a link tag and an image tag or something, but that idea of mixing and matching the context, it's a common enough trick. So it's fun to still see it, but it is something that has been around for a very long time and a well-known trick. So also kind of sad to see it, but great for the attacker. And yeah, I mean it's a fun attack, and then dealing with the CSP with abusing the uh, Chrome password autofill. Kind of just a reminder on, don't use autofill, just manually
Yeah,
fill in what you want to fill in.
yeah, that's
Um
one that we have seen a couple times taking advantage of the autofill. Um,
yeah, it's an easy enough target and reason not to use autofill.
yeah,
He did talk a little bit about needing to like find the right class to hide his things because again he couldn't just inject his own classes and his own styling yet to reuse stuff, but there was a little bit more about the CSP bypassing that might be interesting to you, might not, but on a whole, like still a fun bug. I mean, that sort of class of parser issue is kind of neat to see. Just every time it happens is kind of fun.
yeah. On the topic of Mastodon, one thing I've seen with some of the people who migrated there and then came back is the user interface and whatnot is pretty complicated. It seems like it's pretty featureful but not very intuitive. Um, so there might be like other sorts of issues like this and other functionality. Um, so I mean, yeah, if you're looking for like a target to look at and see if you can find some cool issues, Mastodon might be a good place to look. Um, I do feel like jumping away from the topic or the vulnerability a little bit and talking at a meta level here. I don't really think Mastodon is going to become the new Twitter or something like some people are are thinking it will. But it if it even if it does even grow a little bit, um, having more attention on it from a security perspective makes sense. So it's cool that Portsware looked at it.
Yeah, I think the growth is good. The competition's nice to have, but
Yep,
uh,
competition's always good. So
on a whole, like I'm not sure the federated option necessarily. There's somebody else to point out like they could, have wasn't going to cover this as like a topic on the podcast, but like it just abusing basically the fact that it's federated. So one of those source that gets federated can't just claim anything they want. So you have millions of followers or something. I just made up numbers because there is that lack of like I want to say a lack of trust aspect to things.
lack of centralization,
Yeah,
basically.
centralization.
Yeah.
And that like while I definitely see it as a benefit in some ways, and in fact some people will probably see that as a feature, it also means that it fills a different gap than like Twitter, which does have a bit more centralization or a lot more centralization.
Yeah.
But I think that's going off way off topic for podcast.
All right, so we'll get into our last topic, which is a CVE posted by Mozilla on cross-site tracing via non-standard override headers. And this one got a bit of discussion in our Discord, especially where it's a bit interesting because Mozilla issued a CVE for it and fixed it in quotations, really mostly mitigated it. Um, Even though it's an issue that targets servers using non-standard headers. So it's something that's not really Mozilla's fault or responsibility, but they did put some effort into mitigating it. So yeah, it spawned a bit of discussion. We thought we'd cover it. There's not really much on the Mozilla post about it because it's not really their problem, as I said. Um, but yeah, cross-site tracing is a bit of an interesting thing that again we don't really talk about because it's kind of been dead for a long time. And I know that's why you found it interesting, Z.
Yeah, just the title alone really. made this kind of stand out to me because cross-site tracing has been dead for a long time. It is not the idea used to be, if you're not familiar with a trace request, is it's another verb, kind of like get or post, put, delete, whatever. There's also trace. And what trace would do is it's supposed to be a bodiless request, so you just send headers over with trace, and then the response body will just be all the headers you sent over. According to the spec, the server can remove any sensitive information out of those headers. Realistically, that doesn't really happen. If a server supports trace, it will tend to just reflect whatever was sent to it back. So that means if you had a cross-site scripting, again, we're talking like the 2000s, not like the last decade, but going back a bit more, you would be able to then use your XSS, make a trace request, and get all the headers, and thus access HTTP only cookies, which weren't as popular back then, but that's part of why it's not allowed anymore, is the fact that you could do this sort of cross-site tracing where you would just make the request to see all of the sensitive headers. My opinion here, as Spectre also kind of indicated, I feel like this is more on the servers for allowing you to send like a GET request alongside this X HTTP method override or other headers and have that GET request treated as a trace. Like that feels like a server issue to me. It's doing the wrong thing. It should not have that as a feature. But Firefox did patch it. I did actually find the patch for this also. And it's more or less what you would expect. It just checks the method or just checks the header that you're trying to set and checks the value to make sure it's not something that resolves to one of the headers that it's concerned about, connect, trace, or track. More or less does what you'd expect. But yeah, those three headers are kind of what they're protecting and only against trace, which kind of makes sense that you don't want an XSS to be able to perform a trace. Like it makes sense from like a defense in depth thing. They're protecting their users from having this abused against them. So like I understand Firefox doing it. I'm not against that move at all, but I'm not sure it's worth like a CVE. Although I did look up the CVE for this one, and it is one of the rare cases where they actually had scope changed as part of this, or as part of the CVSS score. And that makes sense. Like this is a case where exploiting it results in a change of scope. So it is one of those cases, but I don't know. It feels like I'd agree with them doing this as a mitigation. I just don't know about it as a CVE. That's kind of my
Yeah,
take on it.
yeah, because it's easy to look at it like you see a CVE on the Mozilla security page, and you're like, okay, so it's a Mozilla bug. It's just it seems like easy to misattribute the bug to like Mozilla as opposed to it being more of like a improve like a mitigation ad. I agree. I don't really think it should be a CVE, but it's a good move by Mozilla still.
Yeah, and I don't know if
And yeah,
Chrome does this. I meant to look into that.
yeah, I'm not sure. Um, but I found it surprising that like sites would even do this at all. Like would support this non-standard header for doing tracing. I'm not even sure exactly why you would want that. Like why you
Even
would go out of your
worse
way to add that.
is there sites that support this over a get parameter, like underscore method being sent as like method equals post or put. Um, or trace. I haven't tried trace with that. I'm not sure if that would necessarily work for some of those things, but I've seen applications and libraries that support like a method as like a get parameter even. And so that's worse because that can be exploited um a lot easier than a custom header like in this case. And I think part of the reason for that is just some tools maybe only want to really provide you get or post. And so if you want to use like a REST API, you kind of need to fake it. He'll send a post, but oh, actually treat this as a put or a patch. Like it does have its place. Not necessarily for overriding it to trace, which generally isn't really I guess I could imagine somebody using trace as part of a REST API for like telemetry or something like that, debug logs maybe. I could imagine an argument for using trace, I guess. Uh but yeah, I believe that's more the reason why it exists.
Yeah, fair enough. So yeah, I mean, not really too much to this issue. It really is just the fact that some of those non-standard headers exist, and Mozilla mitigated it. But yeah, it was a bit interesting because of the context surrounding it. So I thought we'd give it a quick mention on the podcast. So yeah, with that out of the way, that's everything that we have for the week, I believe. So Z, unless you have any parting thoughts, we'll go ahead and wrap it up.
Yeah, no shout outs.
All right, cool. So thank you everyone who tuned in. VOD will be up on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. Our Twitter and Discord links are in the chat and down below for those in the video. And yeah, we'll be back tomorrow for the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.